tutorial covers quite briefly the climatic zones of the world and how the UK fits into that. It has nothing whatever to do with the current arguments for and against global warming. This is simply trying to show why the Earth is divided into different climatic zones and what causes them. One of the main things, obviously, is how the Earth lies in relation to the Sun at different times of the year. Thus you get two seasons developed straight from this, summer and winter in each hemisphere. The Earth is tilted on its axis and it revolves around the Sun, so different areas of the Earth are placed nearer or further away from the Sun in those differing seasons. Obviously, this has the effect of making one part of the Earth warmer and another colder, that is, the summer and winter for each hemisphere. As the Sun travels in relation to the Earth, that is, either north or south in this movement, so different areas of the Earth receive differing amounts of radiation, heat if you like, from the Sun. Depending on the distance of each area from the equator will govern the amount of heat and thus the amount of moisture that each area can create in the differing seasons. Equally, the nearer that area is to the equator, then the warmer that region will be whatever the season. Thus, polar regions are always colder than equatorial regions. This difference creates the basic air movement between the two extremes, and this in turn is further complicated by the spin of the Earth. Basic physics teaches us that warm air rises, that's because it's less dense than colder air, and thus colder air, because it's denser, will tend to sink. We thus have the very first basic idea of heat exchange between the equator and poles. Due to the spin of the Earth, the simple idea is more complex. As warm air from the equator rises and tries to move north, the spin of the Earth, called the Coriolis force after the man who discovered it, causes that parcel of air to be deflected to the right. Thus the air is given an eastward moving component. This in turn creates the much more complex system of exchanges of warm and cold air between the equator and poles. That diagram is on in front of you now and seeks to show this in a relatively simple manner. Spin of the Earth, the simple idea, is more complex. As warm air from the equator rises and tries to move north, the spin of the Earth, called the Coriolis force after the man who discovered it, causes that parcel of air to be deflected to the right. Thus the air is given an eastward moving component. This in turn creates the much more complex system of exchanges of warm and cold air between the equator and poles. That diagram is on in front of you now and seeks to show this in a relatively simple manner. As you can see, this in turn develops the basic climate regions of the Earth shown in the next picture or diagram, and each one is mirrored north and south of the equator. So, as I say, the diagram below shows the main areas of both ascending and descending air. Ascending air leads to precipitation, both in our area, the equatorial and the tropics. Opposite to this is descending air that leads to the major dry areas or desert regions of the world. So far there's been no mention of land or ocean. Inserting these creates quite large differences to the climate at about the same distance from the equator. The prevailing wind also has an effect on modifying the expected climate for various areas of the world. A further complication crops up when we put topography into this equation, both from the actual height effect of the mountains. Remember again, basic physics teaches us that air cools at between 1 and 3 degrees centigrade for 300 meters, approximately 1,000 feet, and the physical effect of a mountain chain across any wind flow as well. One can, I hope, see that these three additions already create even more complex changes in what appeared initially to be similar climates at about the same latitude. That said, we can, relatively easy with these regional or local effects, show the basic weather patterns in the major climate areas of the world. As already mentioned, the climatic zones north and south of the equator largely mirror each other. So in this particular tutorial we'll just deal with the northern hemisphere. And you can split it into basically 6. You will see many geography books and climate books. Meteorological books will have subdivisions of this, but essentially they're down to about 6. That's the equatorial, tropical, subtropical, temperate, disturbed temperate, and polar. In this next diagram I've actually simplified them even further, so from top to bottom if you like. Polar in blue near the poles, disturbed temperate, our climate, tropical below that, and equatorial. And you can see sandwiched between disturbed temperate and tropical is the subtropical high. So we go on and have a look at what each of the types of weather are in these zones. Before that, let's just look at what the air shown by those arrows on the left hand side of the diagram give indications of. Remember I talked about hot air rising and cold air descending. Well, if you look at around the equator on the left hand side there, you can see the air rising and flowing outwards up towards a subtropical high, where it descends and flows back, some of it, to the equator. Some of it actually descends and then flows north and south, both high level and low level, and that is repeated as we get into the polar front zone, into the poles. You can see basically that air from the poles is descending and then flowing along the Earth's surface until it comes along where the polar front is, and there it gets mixed up. Some of it rises, some is flowing in from the subtropical high, some of it is flowing out. It's a very complex process, but essentially those arrows on the left hand side there give a fair indication of what the air is doing three-dimensionally, that is, without that complication of the Earth's spin. So, to explain what the different climate zones generally show. The first one we take is round the equator, oddly enough called the equatorial zone, and it's the one marked in red. At the geographic equator, this coincides with the zone of maximum temperature as the sun tracks north or south of this equator. In both cases, the low-level winds create convergence. Convergence tends to lead to air rising, so the very moist air is forced to rise, leading to the two main wet seasons in the equatorial zone. They occur in April and October. The weather's hot and humid through the year, with no real dry season and frequent precipitation, usually in the form of intense showers or thunderstorms, so mainly convective cloud forms as the originators of this precipitation.